Now I'm waiting for Snehal to come back. Oh, he's here. Great, great, great. Okay. Thank you very much for coming, and good afternoon, everyone. It's a great pleasure to be back here in CEPT in this very auditorium. I was here I was a member of the 85 batch, and Bharat was 12 years my senior, 73 batch. But unfortunately, our paths did not cross in CEPT. But over the years, as we traveled around the world, I always managed, Bharat was always a few years ahead of me. And in CMU, in Zurich, and then in Australia, and I followed him literally and metaphorically and intellectually as well around the world. And it gives me great pleasure to be here today to speak at this event where Bharat's books have been donated to CEPT Library. And I'm sure many of you will have the great fortune of seeing some of the books and using them in your own work. Before I start, though, I'd like to thank two people in particular. Malaben has asked me to do this honor. I would like to thank Professor Paolo Tombest, a very close and dear friend and colleague of Bharat, who has gone into great lengths to make sure that this event happens. And he has not only tirelessly worked to bring together the forum, but is continuously working on the idea of Bharat's legacy and pioneering work in computer-aided design, and ensuring that it reaches CEPT and that it has a permanent home here and grows. So thank you, Paolo, from Malaben and all of us. The second person that I'd like to thank is, of course, none other than Snehal, who I remember from my very first year. A couple of years into my studies here, he arrived from the AA, and his seminal work was the water structures of Gujarat. And we used to marvel, go to the library and read all these wonderful things that he was doing and fantastic drawings. So it was a great inspiration. But Snehal has always been a great lover of books. And as you saw that, his lectures were always about the books and the quotations and history of architecture. And we would like to thank you, Snehal, for taking the big steps in ensuring that CEPT library grows, and also the review. We received a copy of the review, CEPT review. It's fantastic, and I think that all these good works will continue. And it was also a great pleasure to hear Rahul and the others speak. Peter Scriver, old friend of mine. So I could wander off into memory lane, but I won't do that today. I have 25 minutes. And when Paolo asked me to speak about Bharat, I felt that I could speak about my entire work, because there is a little bit of Bharat in everything that I do. And I chose one topic, which is something that Paolo hinted at, which is to talk about my modeling of Indian temples. So, as you know, the Indic temple tradition is a very old tradition of architecture, and it covers not only India, but also Southeast Asia. It started about, well, there are disputed dates, but about 450 AD, and it went on for a long period of time. It continues today. But the period that I have been looking at is 500 to 900 AD, about 500 years of temple building, not only in India, but across Southeast Asia. And I look at temples which are extremely small and quite simple into their construction, their techniques, the thinking, and mostly their geometry. And I'll share that work with you, because I think that would be very interesting. The second one, of course, is to talk about the great love that Bharat had for visualization and immersive technologies. In fact, I didn't meet him here in CEPT, but I met him in Adelaide when I was a PhD student there. He organized a workshop on environment visualization. And what that meant was that we had a series of lectures over a period of 2 days from climate scientists, visualization experts in chemical modeling, geophysicists, people dealing with the environment and its visualization. And he put them together in the architecture school, if you remember, Peter. I don't know if you remember that. And we had a wonderful discussion, interdisciplinary discussion, around what computing technologies and visualization technologies might mean. And so in my second part of my talk, a third part of my talk, I'll show you my own lab, and the one at Curtin University, which is inspired by Bharat. And we continue to progress the thinking that he had about architecture, connecting in an interdisciplinary way to the larger world that is around us. And finally, I'll talk about my own interests and two projects in India that we are just beginning to start after many years of struggle. One would be the street networks of Varanasi, which I will not show you today, maybe on another occasion. And the other one is on the digital handbook of temple architecture that we are building with citizen conservation. So using social media to collate material around conservation sites, as well as high-end digital technologies. My role here in India, the Indian Institute of Technology in Kharagpur, is essentially driving these two projects. And it's a great honor to be part of that system and also to re-engage with India in some sense. And Bharat has always had one foot in India. He looked at many of these issues that we discussed earlier on. He talked about, how do we understand the tradition of India and India's great intellectual tradition, but also building tradition, and how do we locate it within the fast-changing technological progress that is going on. Not all of it can be imbibed, but how do we keep our tradition, at the same time not lose the innovation, the disruption that comes with technological progress. So in 30 minutes, I'll try to cover all of that. And I'll start off with, okay, so I'll just give you a little bit of a background. I don't want to bore you with technical stuff, but essentially, the background is architectural collections are data sets of related building corpus at multiple spatial scales and multiple modes of representation. So you can look at a set of buildings rather than looking at an individual building. How does one look at a set of buildings? One can talk about style, one can talk about materials, one can talk about genesis, but how do we look at a related building corpus? This is one of the big key questions that computing really challenges us to look at in terms of architectural theory or modes of representation. The second one is that in this process of looking at corpus of buildings, I think Paolo talked about routine production and symbolic analysis. We tend to come up with a lot of representations, which you also do in the studio and in architectural practice. You have plans, sections, drawings of various kinds, handbooks. Okay, so we need to look at how can we select, preserve, maintain, collect, and archive these digital assets. Now, most of these routine production that happens, your plans and your sections can also be turned into symbolic representations. This is the beauty of using computing. And I'll talk a little bit about the temples and their digital assets and how we use it. So we are talking about photographs, point clouds, which you can scan, profiles that are extracted out of those point clouds or plans, constructive geometry, so single line drawings, which are flexible parametric models. Some of you may be using that. And then finally, three-dimensional constructions. And I've left out one more, which is the physical asset. So we can go from the final three-dimensional model to the actual physical object. And this is going at a very, very fast pace. Now, the interesting thing is that all of that doesn't have a linear history. You can jump and leapfrog. So for example, because it's technology, you can apply it at various scales and various modes, and I'll do that over this talk. The other thing that I would talk about is this lab that we have built at Curtin University called Hub for Immersive Visualization and E-Research, and this is actually founded on the first lab that Bharat did in Melbourne University. So we've got 4 large displays, and we look at visualization, simulation, communication, and sharing of digital data. So how do we take all this information and put it into a large immersive environment for dissemination, for use and consumption? So we have, I'll talk a little bit about the systems and show you some work, possibly a video if there's time. So now let me just give you a brief overview. This is many years of work. These are the sites that I've been working on, looking at related temples, starting off in central India, a little bit in south, and so on, moving into Thailand, Cambodia, Vietnam, and also Indonesia. So and now we've just started working on Myanmar, you know. So the Indian building traditions are not just located within the geographic boundaries of the country and not within individual time periods. They go over space and time. So one of the things that we did is that we measured these temples across, as I said, from the 4th, 5th century to the 9th century and took a few sample examples across this region between 400 and 900, and we compared them computationally. So we built models which were not just routine drawings, but they were symbolic systems that could be compared. And there's a book that is out, and I'll give you some details later. But before I go into technical details, the motivation for this, why do we want to use computers? And this is precisely the point that Paolo raised and others have raised, is that you want to do as little of the routine production as you can and move up the value chain into symbolic systems. And architecture, traditionally, you know, one uses drawings not just for routine production, but also for symbolic analysis. The computer does it even better, provided you can do the symbolic analysis and represent it, and then generate drawings, generate models, generate specifications. Some of you must be familiar with these new tools, but theoretically, the motivation really is to look at understanding the spatiotemporal spread of these ideas, the typologies, the morphologies, over a vast period of time, 500 years, across India into Southeast Asia, and vice versa. And then the second one is really to look at digital reconstructions to fill in missing information. You'll see some of the models, they have missing information. You know, pothole relationships, fragments. Keeping up with emerging technologies is an absolute nightmare, even for a researcher like me. You know, every 18 months there are new discoveries. It's when you're at that edge, you're constantly learning and you're constantly outdated. So this is a big challenge because the systems that you use, you know, how do you keep track of the changes and how do you keep up with the changes? And it's even worse in practice. So as a full-time researcher, you know, we are struggling to train our graduate students, researchers, and so on. It must be even worse in practice. But keeping up with emerging technologies is absolute given in architecture now. There's no way we can escape that. So the other one, the third one is also a very important one, which is the socio-economic role of both tradition as well as technology. Seeing heritage as cultural capital, and many of you in CEPT are already immersed in this idea of cultural capital, of seeing the heritage as something that can be exploited for economic gain, for living communities, and also looking at environmental knowledge that is, you know, captured in these heritage sites in terms of how people use land, water, and place. So it's not just about technology, it's about understanding the relationships between rapid change and things that remain the same. So in my own work, I was fascinated by temples. I started here with a thesis in CEPT, and that has continued into a lifelong passion to look at the temple building traditions. I was more interested in their geometry first, the construction, the intricate carvings, and I was also interested in the fact that they looked visually related. They had a very strong sense of canonical prescription. And as you know, a lot of these temples were not, in a sense, creative. There was experimentation, but they had underlying rules, okay? And then I was also fascinated by the fact, this is Bagan, that you had very large temple cities. You know, so you start with a very simple shrine, which is hardly, 2 meters, 1.5 meters, maybe 5 meters high, and then you get a huge complex. Okay, how did that happen, and what were the structuring mechanisms that tied these things together? And this happens actually in the 9th, 10th century. Before then, you have individual buildings. In the 10th century, something dramatically changes, and these things get absolutely humongous. As some of you know, in Cambodia, they become entire temple cities. There's a massive change of the landscape with the temples and so on. So I was interested in that, and I wanted to use computing to do that. So essentially the process, I'll just go very briefly through, is that you first acquire the data, and the data acquisition phase, like in any good project, you need data. You can do it in field, you can look at archives, and you can also use some computing techniques like photogrammetry, laser scanning, and so on. measure drawings, very important to be able to measure and survey data on the field. So this is the first option. Sorry, I'm going backwards. The second thing that you need to do is the processing of that data. So you use tools like parametric modeling. You must be hearing that word a lot, or using it, and we use it a lot. And then once we make these models, we have these what we call dissections. So we cut the model into slices at horizontal scale and vertical scale. So we get slices for 2D and 2D vertical dissections. And then we create a model, okay? And then we do virtual reconstructions, which is what you see here. And then we have scale prototypes, which is the printing, 3D scalar printing, which I'll show you in a minute. So the idea really is to be able to use this to build stupas. This is Myanmar, the project in Myanmar, to look at the relationships between the origins of the stupa and the cella in Myanmar, and its variations and how it combines, these two ideas combine to create a large number of buildings, monument ensembles. So it kind of is scaleless in some sense, because computing allows you to work at multiple scales, right from the detail up to the city, even regional scales. It doesn't have any respect for scales. So here is the result of one of our projects. It is 34 temples which go from 400 to 900, as I mentioned, and from the Gupta period in India, Java, and Cambodia, and these are the plans and their timelines. And they're very small temples, and here is Nom Kulen, which is, now they have found a new city in Cambodia underneath these temples, or around these temples. So as you can see very quickly, in a visual way, you can get a sense of the classification of history using a very simple technique of comparing plans. You could do it also manually. So the framework essentially, as I said, is, I guess I've explained that what happens, you get your data, you import the geometric and material data, you get your point clouds, you create surfaces, solids, and then the final bit that we do here is what happens when we take the model and we turn it into a virtual model with a gallery or a landscape, and we put it into our visualization lab. So maybe what I'll do is I'll just show you some quick glimpses of the different kinds of models and representations. So these are basically point clouds. I think this is a mesh. So this is something that comes out of laser scanning, and it captures in great detail. You can go to a great amount of accuracy, and then you can turn it into a mesh representation. You can voxelize it. This is what we are now working in IIT Kharagpur on a new modeling technique with voxels, which are 3D pixels with like little bricks. And you can change their size, and I won't go into too much detail. This is the old representation of looking at profiles, horizontal profiles and vertical profiles. And by the way, these are all flexible representations, so we can control them by code. It's not just drawn by hand. And then, of course, we can do things like, standard visualization and sectional. You probably do that in your studio. So essentially, these representations is what we want to collect. And in the old days, 15 years ago, to do photogrammetry of a temple would take a long period of time. Today, you can do it in minutes on your iPhone. And all the technology for autonomous vehicles and so on, they're all linked to this idea of laser scanning and photogrammetry. So very interesting technology, and they've advanced very fast. So the first models that we did would take months to do manually. Now we can generate these models literally in minutes. Maybe not that perfect reconstruction, but certainly somewhere close to the 3D models. So the project that we're doing with the Government of India, Ministry of Culture, I think it is under the imprint proposals. It's a national project, 3 years. We're going to create 3 data sets, one in Gujarat, one in Orissa, one in Karnataka, of our heritage sites with the ASI. And we're going to use laser scanning, photogrammetry, citizen conservation, photographs, absolutely everything that's available, and put it into a portal. And we're going to try and use some of these techniques that we have developed to structure this so it's available to conservationists, to conservation architects, historians, scholars, and see what happens. And this will be one of the first projects of its kind, and it's a fairly ambitious project, and so hopefully we'll be able to show you some results on that as we go forward. Just coming back a little bit on the constructive geometry, I won't spend too much time on it, but essentially the Indian temple is built out of very simple rules which use the square grids and variations and fractional ratios of that grid, and to generate almost all the detail and the geometry. And so here is an example of the curvature of the temple that you must have observed in the Nagara Shikhar. And if you analyze it and you can code it in the computer using the rules that are written in the textbooks, and they're quite vague rules, but you can start to understand it. So we do it in both ways. We try to understand the text, working with scholars, and we also try to analyze the geometry from our scans. And then we develop these computer-generated models of temples, okay? And based on these rules of curvature, of subdivision, and so on. And you can see your Vastupurusha mandala there, those of you who are aware of it. And then we also do another one which is very complicated, which is what happens is that this construction looks monolithic, but it's not. It has to be made of stone, and it has to be cut. And it has to maintain some of those prescriptions. So they have very elaborate ways of working out the construction units and the carving units. And this is an attempt here to visualize, how they would have possibly figured out the construction unit and the carving units in the temple using digital technologies, right? So this is a further level of detail. So I guess, if you think of 3 levels of detail, this is looking at a single motif. This is about 1 meter by 1 meter piece. And it looks like this on the face of the temple. And then we have to model it as 2 surfaces, which contains some geometry, which then is changed by the algorithm to fit into that particular slot in which it belongs. So this is basically mass customization. This is what we do now in digital architecture. If you look at the projects that are happening around the world, this is a parametric modeling. But this was happening without computing, without code, in the 9th century. And so essentially this is the tradition of architecture. It's nothing new. It has always been there, and it will continue to be there. People will work out ways to relate parts to wholes and figure out techniques. But when you start to unravel this, the complexity goes away, because the complexity is made by the carvings and the ornamentation and the geometry are all part of a larger system of routines that people are applying and experimenting with. So we are trying to use the technologies to figure them out. So right now it was really pathetic because, the temple traditions have been lost. And the sophisticated geometry that we are talking about, many of the people don't follow it, or they don't believe it, because they now take a cast from a new temple, old temple, with a plaster cast or some kind of fiberglass cast, I'm not sure what they use, and then they replicate it. So we are trying to demonstrate that, look, there are some rules available here. This is a symbol system, and you can generate these if you understand the rules. So I guess technology plays a very important part in understanding the tradition of these buildings. This is a very interesting example from Cambodia on the banks of the Mekong River. The reconstruction, essentially this is what's remaining of the temple. It has warped. And so when we do photogrammetry and laser scanning, you sort of get that, as an output. And you can look at the surfaces, you can measure parts of it, but you can't really get. So the trick is, how do we go from this and that into trying to conjecture what the original temple might have looked like, because it's got large cracks on it, made of basalt stone, drywall masonry, which has cracked open. And this was an experiment to try and figure out, what is conjectural and what is original, because you see many models being made. How accurate are they? And so we are trying to develop a system by means of which you can have multiple models at every stage, so people can understand, where you've made assumptions, where its original data, and this is also part of our project. So the next one, this is also a complicated one. This is in Cambodia. So the temple itself follows an ideal geometry. Obviously, you have the Vastupurusha mandala, but it doesn't fit into the original new temple anymore because the bricks, this is a brick temple, and it has warped in various directions. So the trick is then to find out, how much it has warped, where is, where do you start when the building has actually modified itself over a century, or several hundred years, or maybe 1,000 years. So these are sort of some of the questions, technical questions that we are faced with. And eventually we sort of take a whole series of these temples and try to look at their, proportioning systems, because we quickly realized that these are all the dissections in plan allow us to unlock the geometries and the proportions of the entire system, because it's based on rules. It's not whimsical in some sense. So again, that's the same problem that I've mentioned, and this is a problem right through the world. When you have a temple that gives you that, it's how do you come up with this, and how authentic is this, and so on. And this is an interesting question that is debated. And it's been debated since Walter Benjamin, talked about the art of mechanical reproduction, right, and replicas. And I'm very interested in that, the original and the replica. But just to switch gears, this is our immersive lab, and this is what we do. This is actually looking at the screen, and we have a virtual gallery. So every year we do full-scale models in the studio, and then we pin up the student work and drawings inside. And so I use this idea to develop a virtual gallery for the temples and to try and place them into some sort of context where people can experience all these models all at once. And I think I'll just skip that. That's a video of the lab. I'll just show you the kind of systems that we're using. And this is because Bharat was very interested in these types of things, as you heard from the previous speakers, and he was involved in designing and commenting on some of these ideas. This is a hemispherical projection which allows you to look at cities, particularly cities from the sky, and gives you an immersive experience and an overall view using a fisheye lens. This is also a similar system, but it's like a circle, so it's really good for people with disabilities who can move through spaces or heritage sites that they would not otherwise have access to in a virtual world. This is the design of the cylinder that Bharat had something to do with, which built on his lab that you mentioned. We've built a bigger one which has a diameter of 8 meters and a height, 3 meters height, with 6 motion sensing devices, 3 large projectors, and it's called the Hive cylinder. And this is part of that Hive cylinder that I showed you earlier. And this is sort of the scale of the display. And we try all sorts of computational ways in which we generate context and place these for people to look at and for our own research. This is a temple from South India. And as you can see, this is a person looking at manipulating the model. It's full scale, 3 meters high, 8 meters wide, and you can manipulate it with all sorts of tools. We have sort of a space mouse here and some measuring devices, which allows you, this is the gallery context that I mentioned, and we place the models in a certain sequence, and people can experience them. Unfortunately, we don't have glasses here, but so you will see that this is blurred because it's a stereoscopic visualization, and you will see a left eye and a right eye is superimposed. But this gentleman over here is wearing the glasses, so he doesn't see, he sees the perfect visualization, immersive, and he can control it without any device because he's got a little antenna on his head, and you've got the motion sensors, 3 at the bottom, 3 at the top, and as he moves through, he will be able to walk through the model. So I'll just show you a quick video to give you a sense of. Yeah, so that gives you just sort of an idea. So he's moving around. He doesn't have any devices except for the antenna, and he's able to inspect this model as a model, as a replica model at large scale. So we're talking to all kinds of people, developers, builders, government agencies of how they might be able to use this large screen to look at proposals, to look at models, and it's built at a fraction of the cost of actually making physical models. So I guess that was really the part that I wanted to share with you, and I'll end off with talking about the material side of things. It's not just about the digital technologies making wonderful models in a computer screen, but the digital technologies allow you to bridge that gap between the digital and the physical as well, and now with also the physical to the digital. So when you look at a temple such as this, you often wonder, is it enough to just make 3D models? And wonderful models they may be, but they're still digital. So we've also got a research project where we look at digital fabrication and looking at volume and material data and how we can grab that and reconstruct. So I'll just share with you I may have some quick slides because of lack of time, but essentially what happens is that you have the same process. I'm using a different project. This is a tiling project, but you can relate to it. You have the same sort of data, and then you have the solid models, which you can then cast using a fabrication process or a 3D printer. This is an additive process, and then you get a physical model. So you can go from the points, lines, and the geometry. And the beauty of this is that, it goes, as long as your models are correct, you can have a very high quality of finish. Now, what does this mean for people who are crafting things? And I think that this is a big question, probably, that we need to answer. But in terms of our own work, what we are doing is we're using a Z-Corp printer, which, by the way, Bharat was a co-investigator of. He was the main investigator. We acquired some machines. Part of that was the lab that he built in the University of Melbourne. I got, being the most junior member of the team, Mark Burry was the other person who got the big scanner, and I got this 3D printer as part of the Australian Research Council grant. And so I put it to very good use. I started printing models of temples, which is what I had, and started to increase the size. And we are hoping to build not only larger objects, maybe even full scale, but also highly detailed objects, through 3D printing. So this is an example of a part of a temple, and it's a resin, so it looks very synthetic, but this is the cheapest material, so we use that. So you can see the level of detail, that you can get into, because it's basically part of that model. But eventually we will probably start to look at stone or, reconstituted stone, and then we'll start to think about how we might move it across to, these temples. So it's a very exciting field, when you look at tradition and you have technology as your ally, you have some real vistas that open out. This is, of course, I wanted to end with this slide because this temple is still with me. I started with this in 22 years ago, maybe 1993, maybe 2. And I'm still working on this temple. Except that I've changed my tool. So the tradition is still there, and I'm sure my thesis is there in the library. But now I'm using very sophisticated techniques, not only to make the model, but also to cast it, to make casts, full physical casts. Of course, the material is gypsum plaster, but we are not too far away when we'll be able to do this in stone. And this opens up a whole new challenge, when computers are able to not only document, which is what we are doing right now, but help us build, What does that mean to us? Do we go back to another age of master builders, or do we become irrelevant because we stick to our old ways, or do we adapt new ways and become part of the disruption cycle? This is a very big question for us. So what are the trends? We are seeing, at least from the research perspective, the trends, I basically put it in 3 different categories, and this is also something that I've discussed with Bharat, so I thought I'll end with this. Enhanced design space exploration. What does that mean? It means that now we have the power, if you do a project now, you may make at most 2 or 3 options if you're doing a small house. If you're doing, maybe 5, maybe 10 options, I'm not sure. But it's still order of magnitude smaller than what's possible. And we are already seeing the ability to look at routines, routine buildings with multitude of options based on the constraints. And I haven't had time today to show you some of our projects in that sphere, things like land subdivision, housing, you name it, anything that is routine and requires combinatorial studies, you can do it in exponential form, So increasing option means that architects will no longer produce, well, they will produce single buildings. In the end of the day, you'll have one building. But your client will be demanding, your clients will get more demanding. They will want to know what happens if I change the parking from 600 to 800 cars. What happens if my hospital has 8 floors and not 3? What happens if the city has a density of X and not Y? So that power comes from technology. And it's very important that we as architects recognize that our clients will be demanding this of us. And we'll have to be meeting that challenge. Advanced analytics is really, a buzzword, I guess, but it has to do with optimization. Things like, air quality, daylighting, energy usage. This will become part and parcel of designs, and we'll have to find ways, and we are best placed to do it. Both to generate options for our clients, to generate analytics for the industry, to be able to measure, and finally the file to factory process. So file to factory is essentially a process where, the whole idea of producing drawings becomes redundant, and it's already happening. There's no point in spending 40% of our time producing drawings when, if you're clever about it, the files you're generating can go straight somewhere. And it doesn't have to be a mass-producing factory. It could be a craftsperson. It could be a market exchange for parts, for windows, for whatever it is. There's a huge disruption that is going to happen here. It'll become increasingly the norm. And so what are we going to do about that? Are we going to seize that opportunity and say, okay, we are going to disrupt and we're going to be part of that process? Or are we going to say, well, this is too difficult and this is not architecture, we'll continue to draw? You see, so this is the question that's in front of us. So one of the things that Bharat taught me was that, I like theoretical research, I like geometry, I like to sit in, I don't like to deal with industry. But he really made a fact that research and industry engagement is very, very important. And I think in our field, we are very good at doing that. And many of you are practitioners and want to become practitioners. So certainly you carry some of these genes already. So the way we're going to tackle this is going to be through a research practice nexus. And I think that's the way forward, and that's the way that Bharat would have seen it in the next decade or so. So with that, I guess I'm going to stop. Yep, that's it. Thank you very much.